Hello students, in the previous video I gave you one question as homework. I hope you people have solved that question. And to begin with, the question which I gave you, that was prove that 2 tan inverse x is equal to tan inverse 2x divided by 1 minus x square for x square less than 1. And after giving this question, even if I gave you the hint also how to solve it, whereas just to confirm all the steps, you can just verify the answer. I have done it once again for you. Proof part, LHS, you can start with LHS here, 2 tan inverse x, and you can take it as tan inverse x plus tan inverse x. You can apply the formula which already we discussed. This is a very important formula, and shortly we will be solving few more numerical sums on this formula. So remember this formula, and even this formula is required for the calculus part also. But the calculus will not be using tan inverse x plus tan inverse y is equal to this RHS. Will be using in the reverse order, in the reverse way. Okay, so that will be done in the calculus part. So to begin with here, the same formula has been used here. So we have tan inverse of x plus x, denominator 1 minus x into x. Formula, x is replaced here, y replaced by x, and accordingly we have tan inverse of 2x divided by, we have 1 minus x square, that itself is RHS. OR method I given here, that's one more option we have. Consider, if we begin with the RHS provided, and shortly we'll go for one more method called substitution method. And after learning that method, this method of solving, you feel it more comfortable. So start with RHS. You can make a note. The previous one I had done from LHS to RHS. But now, one more option. You can start with RHS. We find tan inverse of 2x upon 1 minus x square. After seeing all the terms, you need to decide here for replacing any x variable with any one of the trigonometric functions. And by practice, by solving more and more questions, you'll come to know. And for this, we have selected put x equal to tan theta. And meanwhile, what is that means x is replaced by a tan function with some angle theta. So theta is a new term which you are introducing in this question. So after substituting all the term, lastly when the whole function simplifies, theta has to be replaced. So theta is equal to what? That will be decided at the beginning step only. If you will say x is equal to tan theta, theta is one more term introduced from your side. Then what is theta? Theta should be taken as tan inverse of x. When I say theta is tan inverse x, of course the tan inverse x function has to exist. That is, the domain part as well as the range part will move accordingly. So once we declare this, let me come back with the substitution part here. We have tan inverse of, this is 2. X is replaced by tan theta. Denominator I find it to be, it is 1 minus x square, it is 1 minus tan square theta. Now the whole term resembles, I hope you remember, which you had done in PUC first year. Got it? This is 2 tan theta divided by 1 minus tan square theta. This formula already I come across. That is nothing but I should say it is tan 2 theta. Submultiple multiple relations in this formula bandidira. So you can even give the reason here, because we know that because tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta. So that formula has been applied here. That simplification has been done. And therefore we have tan inverse of tan 2 theta. Property of inverse trigonometry will help you. Reduces to 2 theta. And followed by I should say it is theta replaced back. We have 2 tan inverse x, and that itself is LHS. So two methods are given here. But according to my experience, I should say, after learning the substitution method, this method you feel it more comfortable to solve it or to prove this question. Whereas there is no harm if you want to make use of this proof also. Now the next question here we have, if 3 terms are given, prove that tan inverse x plus tan inverse y plus tan inverse z is equal to tan inverse x plus y plus z minus xyz whole divided by, it's 1 minus bracket xy plus yz plus zx. Or you can say even the denominator part as 1 minus xy, minus is taken term by term if the bracket does not exist. If the bracket is open, then I should say it is 1 minus xy minus yz minus zx. Any one thing you can consider. And remember this formula also. To begin with the LHS part here, I hope easily can guess this method. So LHS I declared here, and between the first 2 terms I can apply the formula which already I know it. That is tan inverse x plus y, denominator 1 minus xy, plus it is tan inverse z. Now between this term, tan inverse of this term plus tan inverse z, again between the first these two terms, the resultant has been done. Between these two, I would like to apply same formula, that is assuming tan inverse x plus tan inverse y. We have the result tan inverse x plus y divided by 1 minus x into y. Isn't it? Same formula, ಸ್ವಲ್ಪ careful ಆಗಿ terms substitute ಮಾಡ್ಕೋತಾ ಬನ್ನಿ. So this has been assumed it as x plus this is assumed it as y. Denominator 1 minus x into y. Once you write this step carefully, then go for its lower class algebra only. So what best we can do? Numerator can go for LCM. So 1 minus xy should act as LCM, which I am claiming here. Followed by, let me cross multiply the terms to balance the LCM. We are left out with x plus y plus z plus into minus minus. We have xyz. Denominator LCM kept as it is. In the whole denominator term also, again I find 1 minus xy is LCM. Balance it. Multiply it, I mean to say. It's 1 minus xy. Be careful about this minus. Minus z is multiplied to x plus y. Which I open it here. It is minus xz minus yz. So finally simplification occurs here. We have 1 minus xy gets eliminated. Left out term itself, I think we need to go for it, RHS. That itself is RHS. So this should be proof for this fourth question. Okay. Practice it once again from your side. So once you have done it, the next question here we have, okay, these are numerical sums. These questions can be given for 3 marks question or 2 marks question also. Very simple proof we have here. A very simple question also I can say. Ide similar pattern alli sakastu questions kelbodu. So once you practice, once you're used to for this method, easily you can go for simplification part. So question is, prove that. You can write here 3 marks question. Prove that sin inverse x plus sin inverse y is equal to sin inverse x root of 1 minus y square plus y root of 1 minus x square. So ಈ question prove ಮಾಡಬೇಕಂದ್ರೆ, as earlier also mentioned, whenever I find sin inverse x, I always assume this to be an angle. Sin inverse y, I assume this to be an angle. So accordingly, what I should say here, let us say sin inverse x is equal to alpha, sin inverse y is equal to some angle beta. If this is a part which I am claiming here, obviously I will come for the trigonometry. I find sin alpha is equal to x. Got it? Now the question is, sin alpha is equal to x kotta takshana, what next you can do here? As earlier also I mentioned, you can go for all the trigonometry functions. Andre, sin alpha is equal to x and tagondaga, it's given for a right angle triangle, not required to mention here. Just to help you, I'm giving this clue here. This is alpha. For this right angle triangle here, I find opposite side is x, hypotenuse is 1. So left out side is going to be obviously square root of, hypotenuse is always bada, minus, this is the left out side, I should say it is x square. This is adjacent side. Got it? So using this relation, andre sin alpha kottidare antandre 2 sides are given, and obviously I can find all the trigonometry function. Andre sin alpha kottidare andmele cos alpha, tan alpha, cosec alpha, sec alpha, cot alpha. But out of this, I would like to select only cos alpha here. Now what made me to go for this? That is, in alpha and tagondaga and beta and tagonda, just think about the RHS, what they expect. They expect in terms of sine. Hagidre, I should consider sine of alpha plus beta. What is sine of alpha plus beta? This formula is right now moving in my mind. What is sine of alpha plus beta? Expansion nodkoli. It is sine alpha cos beta plus cos alpha sine beta. So alpha samandpatta hage I am in need of sin alpha and cos alpha. Beta samandpatta hage I'll be in need of sin beta as well as cos beta. So that means when I approach for alpha, I was thinking about sin of a plus b compound angle expansion. So sin alpha x and ತಗೊಂಡ್ಮೇಲೆ obviously I'll go for cos alpha only. ಇಲ್ಲಿ ಬೇಕಿದ್ರೆ tan alpha ನು ತಗೋಬೋದಿತ್ತು, ಎಲ್ಲಾನು ತಗೋಬೋದಿತ್ತು, but I select to go for cos alpha only. So cos alpha, straight you can write here. If you are comfortable with the triangle, please go ahead with the triangle and just make a note and you can write it here. But in this sum, almost theory part it moves here. I can make use of one more relation. Data kuda baribodu because cos alpha is square root of 1 minus sin square alpha no baribodala. The basic kind of trigonometry. Cos alpha is equal to square root of 1 minus sin square alpha, which is nothing but back to root of 1 minus x square. So from sin alpha, I wrote cos alpha. Similarly, sin inverse y beta adre Sin beta is equal to y adre. What do you mean cos beta? Cos beta will be square root of 1 minus sin square beta, which is nothing but y square. So from this I went for this. From beta angle, sin beta, cos beta, I went for these two terms. Now come back with the question. From the question I find which I consider alpha, which I consider beta. So let me consider and trigonometry formula na justify ಮಾಡ್ತಾ ಇದ್ದೀನಿ. I am taking this formula, whole equation I am taking here, the whole formula. So of course I can say cos also here, cos alpha plus beta is also available, sin alpha minus beta is also available. But which formula I have to take here, it depends upon the given question. So as I have taken here alpha and beta plus sin is given and sin is given here. That's why I select go for sin of alpha plus beta. Formula barkoli first to sin alpha cos beta plus cos alpha sin beta. I hope you remember this formula. Okay. Now, what is sin of alpha plus beta? Let me keep the term LHS part as it is here. Sin alpha, I am putting the value x. Cos beta, I am putting the value root of 1 minus y square. Cos alpha, I am putting the value root of 1 minus x square. Sin beta, I should say it is y. Almost we are in the RHS term. Only thing, this formula has to be, compound angle formula has to be rearranged in terms of inverse functions. Okay. Now, what next? So, sin is transferred here. That is alpha plus beta is equal to, we have sin inverse of all the terms kept as it is. Then what is alpha and what is beta? Alpha is replace ಮಾಡ್ಕೋತೀರಾ. We have sin inverse x. What is beta? Sin inverse y is equal to this RHS kept as it is, and the whole term compound angle has been trigonometry. Compound angle has been modified to inverse trigonometry. Beautiful relation we have. This formula, or I can say this is a relation. So last bariyona, hence proved anta. A very simple proof. Okay. So this question can be asked for 2 marks or 3 marks. Prove that question kodtare nodi idana. Prove that kodtare. So very simple target to prove. Okay. Similarly, I find here we have one more question. We have sin inverse x plus sin inverse y. But this time they expect the RHS in terms of cos inverse. So it is cos inverse root of 1 minus x square root of 1 minus y square minus xy. So it is again alpha to be claimed. This is beta to be claimed. From this we have sin alpha, and obviously I go for cos alpha only here, because what comes in my mind is cos of alpha plus beta. Run ಆಗ್ತಾ ಇದೆ ನೋಡಿ ತಲೆಯಲ್ಲಿ. What is cos of alpha plus beta? Cos alpha cos beta minus sin alpha sin beta. Isn't it? So sin alpha into cos alpha ಬರ್ತಾ ಇದೀನಿ. Again beta ಅಂತ ತಗೊಂಡು cos beta we am declaring here. And finally I should consider ಅಂತ ಹೇಳಿ ಯಾವ ಫಾರ್ಮುಲಾ ತಗೋತೀರಾ? Cos of alpha plus beta na formula na claim ಮಾಡ್ತಾ ಇದ್ದಾರೆ. Trigonometry formula claim ಮಾಡ್ತಾ ಇದ್ದೀರಾ. Cos alpha cos beta minus sin alpha sin beta. So here we have cos of alpha plus beta. Put all the values here. We have cos alpha root 1 minus x square, cos beta root 1 minus y square, minus this is x, this is y. Then again cos transferred. We have alpha plus beta as cos inverse of root of 1 minus x square root of 1 minus y square minus xy. And therefore alpha beta replaced back. We have sin inverse x plus sin inverse y is equal to, it's cos inverse of LHS to RHS, hence proved should be the answer. So only thing you have to practice it, okay, and properly you have to understand how the steps have been taken. The next question here we have, I think now I can try this question. Of course, while proving this statement also, all the domain and everything has to be stand. So they are going to give the inequalities also here. Prove that. Next question. Prove that sin inverse x minus sin inverse y is equal to sin inverse of x root of 1 minus y square minus y root of 1 minus x square, where x greater than or equal to 0, y greater than or equal to 0. So again alpha claiming here, beta claiming here. Sin alpha is x, cos alpha should be root of 1 minus x square. Sin beta is y, cos beta should be root of 1 minus y square. So which formula comes in your mind? Sin of alpha minus beta. So what is sin of alpha minus beta? Compound angle. Properly you write the formula. Sin alpha cos beta minus cos alpha sin beta. So once we write the formula, put all the terms here. Okay, just have a glance. You find finally please declare hence proved. Bari the answer na. Conclusion always should and must. Got it? So this should be proof part and solve it. This should be in your notes also. So similarly, I think a few more questions I can give it as homework for you. So here we find few more questions. Homework question. Prove that. You can give a pause and you can make a note of these questions. Okay, I done it. I hope you done it. Yeah. So prove that cos inverse x plus cos inverse y is equal to cos inverse of so and so. Just make a note, and of course for this you can claim for alpha, you can claim for beta, Which formula comes in your mind? Cos of alpha plus beta. Okay. So what is cos of alpha plus beta? Cos alpha cos beta minus sin alpha sin beta itself is the result. Okay. What about this alpha beta? We are going to take the formula cos of alpha minus beta. What is cos of alpha minus beta? Fifth question I am discussing now. It says cos alpha cos beta plus sin alpha sin beta. So similarly, please go ahead with sin of alpha minus beta, cos of alpha plus beta, it is sin of. So in all the expansion, you require cos and sin only. So declare it as alpha and find out sin kotte cos tagond bani, cos kotte sin tagond bani, and just try to prove all these questions. So 4, 5, 6, 7, 8 homework questions for you. Try to solve these questions. Okay. Now, based on a similar result where x and y are not given, we will move on for the numerical sums. Idu kuda tumma important questions. And these questions definitely are going to enjoy it here. So question is prove that. Okay, common heading. Every time you can make a notes for you kuda prove that barkota bani alle. Common heading itkolona alle. So prove that sin inverse 3 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 65. So once again alpha, sin alpha is 3 by 5. Now tell me what should be cos alpha. But possible? See, you can just have the triangle in your mind. You can even go for triangle also. There is no harm. Okay, one triangle na become construction ಮಾಡ್ಕೊಂಡು ನೀವು ಬರಿಬೋದಲ್ಲೇ. What is that? I should say opposite side, hypotenuse, opposite, hypotenuse, left out side. I had asked you to remember the triplets. ಸ್ವಲ್ಪ triplets ನ ಬ್ಯಾಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. 3, 4, 5, 5, 12, 13. ಸ್ವಲ್ಪ ಕಾಮನ್ ಆಗಿ ಬರುವಂತ triplets ಇವೆಲ್ಲ. So obviously I should say it is 4 will be the left out side. So cos alpha is going to be 4 by 5. Got it? So I should say next one I have taken here cos inverse 12 by 13 is beta. So cos beta is 12 by 13. Obviously I'll guess the triangle ಬೇಕಾದ್ರೆ ಮಾಡ್ಕೊಳ್ಳಿ. Triangle ನ ಮಾಡಿದಾಗ cos ಅಂತ ಅನ್ನಬೇಕಾದ್ರೆ this is beta. Cos ಅಂತ ಅನ್ನಬೇಕಾದ್ರೆ adjacent, this is hypotenuse. The left out will be, that is 5, 12, 13 makes it triplet. 5, 12, 13 triplet ಅದು. ಪೈಥಾಗೋರಿಯನ್ ಟ್ರಿಪ್ಲೆಟ್ಸ್ ಅವೆಲ್ಲ. ಸೊ ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಟ್ರಿಪ್ಲೆಟ್ಸ್ ಬಂದೇ ಬರ್ತೀರಾ. ಪ್ರತಿಯೊಂದು ಎಕ್ಸಾಂಪಲ್ ಏನ್ ಟ್ರಿಪ್ಲೆಟ್ಸ್ ಬರುತ್ತಲ್ಲ, you can just make a note on one corner and remember all those triplets. It's going to save your time. Sin beta ಅಂತ ಬರೆಯಬೇಕಾದ್ರೆ I should say opposite 5, hypotenuse will remain same 13 only. So ಈ ರೀತಿ ರೆಡಿ ಮಾಡಿ ಬಿಟ್ಕೋತೀರಾ. And then back to question here. ನೋಡಿ ಯಾವ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ತೀರಾ? Cos of alpha plus beta ಫಾರ್ಮುಲಾನ ಯೂಸ್ ಮಾಡ್ತೀರಾ. Cos of alpha plus beta. Formula mal barkodi. We have cos alpha cos beta minus sin alpha sin beta. So we have cos of alpha plus beta is equal to cos alpha, put the value 4 by 5, cos beta, put the value 12 by 13, minus sin alpha, put the value 3 by 5, sin beta, put the value 5 by 13. So after substituting here, please be careful about simplification part. Minus na madhya tolik hogbedi. Earlier also, I think in the previous video also we discussed regarding the same. So first multiply it. Here we find 12 fours are. Okay, LCM, of course the product will remain as LCM here. 12 fours are 48 minus 3 fives are 15, but 13 fives are after multiplying 65 here, 65 is also here. That 65 will act as LCM, which I have taken here. So calculation, you have to be careful. So once we do it, 48 minus 15, you can just simplify it. We find the answer 33 by 65. So alpha plus beta, cos is transferred. We have cos inverse of 33 by 65. So what is alpha? Replace it back. Sin inverse 3 by 5. Beta, replace it back. We have cos inverse 12 by 13. Itself is cos inverse 33 by 65. Ide enagittu question agittu prove maadi anta. Prove that. And hence we have proved it. Very simple target. So calculation part ide and sariya madkotu banni. ಹಾಗೆ RHS ನಿ ರೀಚ್ ಆಗ್ಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಸಮ್ ವೇ ಯು ಹ್ಯಾವ್ ಗಾನ್ ರಾಂಗ್ ಇನ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಪ್ರೂವ್ ದಟ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ತಪ್ಪು ಮಾಡೋ ಚಾನ್ಸೇ ಇಲ್ಲ. ತಪ್ಪು ಮಾಡಿದ್ರು ಕೂಡ ಆಟೋಮೆಟಿಕ್ಲಿ ಕಮ್ ಟು ನೋ ಬಿಕಾಸ್ ವಿಲ್ ನಾಟ್ ರೀಚ್ ಟು RHS. Easily can wind up or easily can justify, easily can correct yourself. Okay. So next question here we have is tan inverse 2 by 11 plus tan inverse 7 by 24 is equal to tan inverse 1 by 2. Okay. Definitely ಈ ಕ್ವಶನ್ ಕೂಡ ನೀವು ಅಲ್ಫಾ ಅಂತ ತಗೋತೀವಿ, ಇನ್ನು ಬೀಟಾ ಅಂತ ತಗೋತೀವಿ ಅಂದ್ರೆ ನಾ ಬೇಡ ಅನ್ನಂಗಿಲ್ಲ. Definitely can do that. This is alpha, this is beta. You can consider tan of alpha plus beta ತಗೊಂಡು ಕೂಡ ತೊಂದರೆ ಇಲ್ಲ. But let me tell you here. See, whenever we have in terms of tan inverse, okay, always remember this formula has to be used. A ready-made formula available. A ready-made formula, that is tan inverse x plus tan inverse y is equal to tan inverse x plus y divided by 1 minus xy. This formula I am going to use only in the case of tan inverse. Okay, ಆದರೆ sin inverse ಅಲ್ಲಿ ಬಂದಾಗ ಓಕೆ ಇದನ್ನ ಕಾಂಪೌಂಡ್ ಆಂಗಲ್ ಜಸ್ಟಿಫೈ ಮಾಡ್ತೀರಾ ಆರ್ ಈ ಮೆಥಡ್ ಅನ್ನೇ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ ಒನ್ ಮೋರ್ ಮೆಥಡ್ ಶಾರ್ಟ್ಲಿ ಐಲ್ ಗಿವ್ ಯು. Okay, so remember whenever we had tan inverse, this is the best option to simplify. So here find, let's go for the question here. Prove that. Okay, this is tan inverse 2 by 11 plus tan inverse 7 by 20. Okay, 24 is equal to tan inverse 1 by 2. So in this we'll start with ನೋಡಿ LHS ಶುರು ಮಾಡ್ತಾ ಇದ್ದೀನಿ. See the steps, the presentation also counts here. ಯಾವ ರೀತಿ justify ಮಾಡ್ತಾ ಇದ್ರ ಆನ್ಸರ್ ಅನ್ನ. So write here LHS. Got it? So LHS is equal to ಅಂತ ಬರಿತಾ ಇದ್ದೀನಿ. ಇಲ್ಲಿ ಎಲ್ಲಿ LHS ಮೆನ್ಷನ್ ಮಾಡಿರಲಿಲ್ಲ because I was claiming for this, and for this I mentioned let us consider let sin inverse 3 by 5 is equal to alpha. So ಇದೆಲ್ಲ justification ಕೂಡ ತುಂಬಾನೇ important. So presentation also counts here. So write and practice in the same order, in the same manner. LHS is equal to, we had tan inverse 2 by 11 plus tan inverse 7 by 24, and write the formula which you're using here, because this formula is standard formula. I repeat, it is standard formula. So in apply ಮಾಡಲಿಕ್ಕೆ ಅವಕಾಶ ಇದೆ, apply it wherever it is possible to reduce your time. So we had tan inverse x plus y, denominator 1 minus its x into y. So after substituting, it is totally your lower class mathematics. ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ ನೋಡ್ಕೊಳ್ಳಿ, ಎಲ್ಲಿ LCM ತಗೋಬೇಕು, ಎಲ್ಲಿ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ಕೋಬೇಕು ಅಂತ. Numerator obviously I had to go for LCM as we have plus sign in between. So between 11 and 24, LCM begins. 11 being a prime number, obviously I should say 11 into 24. 11 into 24, that is 264 will act as LCM. Even you can make use of calculator also. Calculator is allowed in your exam hall. So ಹಾಗಂತ ನೀವೇನು every time 2 into 3 ಮಾಡಲಿಕ್ಕೂ calculator use ಮಾಡಲಿಕ್ಕೆ ಹೋಗಬೇಡಿ. As far as possible, oral calculation is the best option. But wherever 2-digit, 3-digit multiplication occurs, it's better you make use of calculator to save your time. We have 11 into 24, 264. Balance I should say it is, after LCM as 264, obviously I should say 11 multiplied by 24, and therefore 24 double, I should say cross multiply also. So we have 48, it's 11 into 7, 77. Denominator I should say it is 1 minus. This I have to multiply, unless until not multiply here, don't go for LCM. So I should say it is 14, denominator I should say 264. Now the LCM has to be clear in denominator. So 264 is LCM, 264 minus I should say it is 14. So numerator I have simplified here. Next step, let me explain here. 48 plus 75, I should say 125, denominator 264. ಇಲ್ಲಿ ನೋಡಿ, ಇದು denominator ಇದೆ. So this divided by, let me go for multiplication, into. And I find the denominator's denominator reciprocal. Andre 264 comes in numerator. I should say 264 minus 14. 264 minus 14 is 250. That term has been taken here. Ulta, the reciprocal has been taken. Denominators 250 divided by 264. Reciprocal I had taken as 264 divided by 250. So 264 gets eliminated, and obviously I should say 125 and 250. Without any hesitation, you can say 1za and 2za. Well, left with tan inverse 1 by 2, and that itself is RHS. Is equal to RHS. So start with LHS and RHS. When we have an option of this formula, we can use it, tan inverse x plus tan inverse y. Got it? So it's a very simple method. Okay. Once you practice this method, is also quite easy. But an alternate option also, I mean tan inverse, this is the best option. So 9th question, once again I'm discussing here. 9th question, once again with the alternate option I'm discussing here. That is to prove. Same question once again. After discussing this formula, I should tell you one more option, one more method also. Afterwards it's left to you. Whichever method is comfortable, you can go ahead with that. Ide question togota nodi. To prove sin inverse 3 by 5 plus cos inverse 12 by 13 is equal to its cos inverse 33 by 65. So, e prove ಮಾಡಬೇಕು ಅಂತಂದಾಗ there's no doubt what we had done earlier method. I went for alpha beta and then I went for cos of alpha plus beta formula. But one more option, ನೋಡಿ, sin inverse 3 by 5, is it not equal to tan inverse 3 by 4? Isn't it? So why tan inverse 3 by 4 here? Because I should say it is a right angle triangle wherein we have opposite side 3, 5. So leftward I can calculate 4, and obviously I should say it is equal to tan inverse of opposite by adjacent 3 by 4. So sin inverse 3 by 5 and tan inverse 3 by 4 ಅಂತ ಬರ್ಕೋಬಹುದು. This I am converting in terms of tan inverse. This also similarly I am converting in terms of tan inverse. Nodi also cos inverse 12 by 13 antanu bekadre a right angle triangle for some angle beta adjacent is 12, hypotenuse is 13. Therefore leftward should be fine. So we have tan inverse 5 by 12. Opposite upon adjacent. Straight away can write this, straight away can write this, and therefore once again start with LHS. Note the unknown method or option I am saying. Once again I am solving 9th question. Or option. So now start with LHS. We have sin inverse of 3 by 5 plus cos inverse 12 by 13. So this has been taken in terms of tan inverse. This has been taken in terms of tan inverse. Now you can apply the formula. So what is tan inverse x plus y? Tan inverse x plus y, 3 by 4 plus 5 by 12, denominator 1 minus x into y. Simplification begins between 4 and 12. What is LCM now? Between 4 and 12. What is LCM? LCM tolo gottala ellargo. Got it? Now don't say 12 into 4 is LCM. 4 is the factor of 12. So obviously 12 should act as LCM. Okay. So simplification part. Okay, I have done it here. I find it to be the terms. It is tan inverse of 12 being LCM. It's a numerator term 9 plus 5 denominator 12 whole divided by 1 minus 15 upon 48. Continue your simplification part. You find it to be same terms. We are left with tan inverse of numerator it's 14 by 12. Denominator is 48 minus 15. 48 being LCM minus 15. So 48 LCM I taken numerator because I have taken the reciprocal of denominator. So 48 minus 15 I have taken is 33. Simplify the maximum it is possible from your side. So I find it to be here 12 ones are and 12 fours are. 14 fours are 56. Denominator 33. Cancellation. So once we have this, it is a tan inverse of 56 by 33. Now this result I have to prove it for RHS. Just see the question. What they say in RHS, they say it is cos inverse 33 by 65. So obviously again I claim for a triangle where I find opposite side 56, leftward adjacent side I should say 33, leftward hypotenuse you have to calculate. So this part is not even compulsory to do it also. Even if you prefer to do it also, no harm in doing this. Say a triangle 56 and 33, go for squaring, Calculate is calculate is allowed for you in the exam hall. So ali is a question kodidaralla. It's 33 by 65 antandaga. Obviously 65 will be the hypotenuse, no? Adu barlilla 65 is not even answer antandaga. Definitely it's understood some way you have gone wrong in the calculation part. You can cross check it also. So I went for the squaring and I got 4225. Using the calculator I cross checked it whether it is a square of 65 only or no. So I went for 65 square, I verified it and finally I found the 65 square itself is 4225. So 65 square barkota idani and this made me to go for hypotenuse 65. So obviously I should say it is tan inverse 56 by 33 can be taken as cos inverse of 33 by 65, that itself is RHS. Declare the answer. Got it? Similar next question here we find. Prove that tan inverse 1 by 2 plus tan inverse 1 by 3 is equal to pi by 4. So ready-made tan inverse bantakshan ready-made formula can apply here. Start with LHS, write the LHS. The tan inverse 1 by 2 plus tan inverse 1 by 3 is equal to tan inverse x plus y denominator 1 minus x into y. So numerator LCM 6 being LCM 3 plus 2 cross multiply madidre 3 plus 2 5 by 6 denominator nodi it's 1 minus 1 by 6. 6 is LCM 6 minus 1 5 by 6. Everything 6 eliminates, 5 eliminates, we are left with tan inverse 1. What is tan inverse 1? Pi by 4. That itself is equal to RHS. Similarly, I am sure you can solve this homework question. Tan inverse 3 by 4. Prove that, of course. Tan inverse 3 by 4 plus tan inverse 1 by 7 is equal to pi by 4. Solve this question. 13th question. Prove that tan inverse 4 by 3 minus tan inverse 1 by 7 is equal to pi by 4. Start with LHS. Tan inverse 4 by 3 minus tan inverse 1 by 7. So can you recollect which formula to use it here? Minus plus ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಹುಷಾರಾಗಿರಿ. Tan inverse x minus tan inverse y is equal to what? Is equal to, remember, tan inverse x minus y. Denominator it is 1 plus xy. Isn't it? This is the formula. So this formula I'm going to claim here. Tan inverse x minus y. Denominator it's 1 plus x into y. Calculation begins. We find 7 into 3 being LCM. So I taken 21. Here cross multiply and balance for the numerator terms. We have 28 minus 3. Okay, I done it here. Denominator 1 plus, I should say it is 4, denominator 21. So I take an LCM as 21. It's 21 plus 4. I have balanced it also. So we're left with 25 by 25 tan inverse 1, and therefore I should find the answer pi by 4 as RHS. 14th question, we find tan inverse A plus tan inverse 1 by A is equal to pi by 2 for A greater than 0. So obviously you go for the same formula only. There's no doubt about this. Please go ahead with this. LHS tan inverse A plus tan inverse 1 by A. Isn't it? Tan inverse X plus tan inverse Y formula apply marona. Write the formula which you're going to use it here. Tan inverse X plus Y, denominator 1 minus X into Y. Isn't it? So here we have tan inverse of 1 plus 1 by, I kept it as it is because denominator anyway it is 1 minus 1. Denominator anyway it is 0. So we find it to be tan inverse of infinity. Hagiddaga I should say it is pi by 2. This is equal to RHS, and let me declare the answer. Okay. This is a proof part, no doubt about this. But few questions may come in your mind that see pi by 2 antandaga, especially pi by 2 anta kottaga inverse trigonometry we find beautiful relation, that is earlier also I discussed the property. What is the property? Sin inverse x plus cos inverse x is equal to pi by 2. Similar one more I discussed, tan inverse x plus cot inverse x is also equal to pi by 2. So yavaga pi by 2 anta kodtaralla ille complementary angle, somewhere I discussed in the previous video also, complementary angle. Definitely I find here tan inverse x plus cot inverse x. Can use the property. Think about it. Isn't it? So property will definitely decide the answer is pi by 2. Few may ask the question, but tan inverse infinity in the kottaga, we are giving the result as pi by 2. Why this should happen? Because tan inverse range is, what is tan inverse range? We say it is minus pi by 2 comma plus pi by 2 is open interval. What I said? Minus pi by 2 comma plus pi by 2, it is open interval. Andaga open interval means it's not included. Isn't it? That's why pi by 2 has been taken here. Just to justify the RHS I given. But the correct way to convince you here is the property based proof. Okay, so example ಹೇಗೆ ಮಾಡಬೇಕು? Example ನೋಡಿ question ಏನಾದರೂ 1 mark ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ the best option would have been this proof which I given here, OR method. OR. So what is tan inverse A plus tan inverse 1 by A? It's an OR option. For 1 mark you can go for this. I know it very well. Tan inverse 1 by A is nothing but cot inverse A for A greater than 0. Property ಹೇಳುತ್ತೆ. ಹಾಗಿದ್ರೆ ಕ್ವಶನ್ ಹಾಕಿದ್ರೆ ಹಂಗ ನೋಡಿ LHS ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. tan inverse A plus tan inverse 1 by A. This tan inverse 1 by A itself is cot inverse A. So now I can apply the property tan inverse x plus cot inverse x is pi by 2. Therefore tan inverse A plus cot inverse A is nothing but pi by 2. That itself is RHS. For 1 mark question, even for 2 marks also you can go for the same part, same method of solving. Got it? Question ಏನಾದರೂ 2 marks ಗೆ ಅಥವಾ 3 marks ಗೆ ಕೊಟ್ಟಿದ್ರು ಅಂತಂದ್ರೆ ಸ್ವಲ್ಪ ಲೆಂದಿ ಆಗಬೇಕು ಅಂತಂದ್ರೆ then you can prefer this method. This method. Okay, so but ultimately the answer is pi by 2, but you may have a question here also, provided if ಬಹುಶಃ question ನಿಮ್ಮ ತಲೆ ಬಂದಿರಲಿಕ್ಕಿಲ್ಲ. I think I am raising that question. Okay, meanwhile I gave a solution also for this. So this either this method, both should be there in your notes, or I should say this method. Sometimes marks will give a proper judgment at which method I need to represent there to conclude the answer. Okay. Meanwhile, okay, next question you can take it as homework, and I'll continue the solution part in the next video. So 15th question, prove that tan inverse 1 by 2 plus tan inverse 1 by 3 plus tan inverse 1 by 4 is equal to cot inverse 3 by 5. So 3 terms kottare nodi. 3 terms you find. So how to start with LHS and how to conclude the RHS. Think about this solution part. Next video, let me continue it. Thank you.